Hello everyone. In this question, it is given that for three positive integers pqr, x raised to the power pq square is equal to y raised to the power qr is equal to z raised to the power p square r. And it is also given that r is equal to pq plus 1 such that 3 log x base y, 3 log y base z, and 7 times log z base x are in arithmetic progression with a common difference of half. Okay, so we have to find the value of r minus p minus q. Okay, so first of all, let us start. We are given that pqr are positive integers, which means these are natural numbers, right? So we are given that x raised to the power pq square is equal to y raised to the power qr is equal to z raised to the power p square r. Okay, let us equate each of these terms to a constant, say k. Okay, so from here we are given that x raised to the power pq square is equal to k, right? So if we take log on both sides, okay, with base say x, okay, so then log x raised to the power pq square to the base x will be equal to log k base x, right? So from here, this pq square will come to the front and this will become log x base x, right? So this implies that pq square is equal to log k base x. Okay. Similarly, we can take the second term y raised to the power qr equal to k, right? Y raised to the power qr is equal to k, and if we apply the log here to the base y, we get qr is equal to log of k to the base y, and lastly z raised to the power rp square, right? Yeah, p square r, I am writing it rp square. Okay, it is equal to k. So this time we have to take log with base z. Okay, so this will give us rp square will be equal to log of k to the base z. Okay, so these are the preliminary equations that we have got. Okay, so now we know log x base y times say log k to the base x. Okay, this product, this log x here and this base x here of the next logarithm, these two cancel each other and this gives us log of this k is remaining and this base y is remaining, right? So this becomes log k base y, right? Okay, so from here we can conclude log of x to the base y will be equal to this log k base y upon log k base x, right? I've kept this first term separate and I have divided both sides with this log k base x, right? Okay, so we get this equation. So from here, can we substitute some terms from these three equations? Okay, I am deducing this because we are given this value 3 log x base y, 3 log y base z, and 7 log z base x. Okay, so I'm trying to deduce this expression in terms of PQR. Okay, so we get log x base y. This is log k base y, right? So this k base y, this is QR, right? So we have QR in the numerator upon log k base x. This is PQ square, right? So we have log x base y equal to QR upon PQ square. Okay, so this Q and Q will get cancelled here and we are left with R upon PQ. Okay, this is log x base y. Okay, now let us find this value log y base z and then log z base x. Okay, so again I'll apply the same formula here. Log of y base z times log k base y, say. Okay, this y and this y will get cancelled and we are left with log k base z, right? So in isolation of this first term here, log y base z, this will give us log y base z will be equal to log of k base z upon log k base y, right? So again, log y base z can be written as log k to the base z. This is rp square. Okay, so this becomes rp square upon log k base y. This is qr, right? So this becomes rp square upon qr. Okay, so this r and r will get cancelled and this becomes p square upon q. Okay, so these are the first three equations we have got, right? Then this is another equation and this is another equation, and now we need to find this value log z base x. Okay, so log of z base x, again this will be log k base z, this will become log k base x, right? This z and this z will cancel each other, so from here log z base x can be written as log k base x upon log k base z, right? So this implies log of z base x will be equal to log k base x is pq square. Okay, so we have pq square upon rp square, right? Log k base z, so this becomes rp square. Okay, so we are left with q square upon this p and p square. One p will remain in the denominator, so this becomes q square upon pr or rp. Okay, so this is the other equation. Okay, so we have got the three equations. Now we are given that r equal to pq plus 1 and these four terms are in ap. Okay, so let us first start with this ap part here. Okay, 3 log x base y, 3 log y base z, and I think 7 log z base x. Yes, 7 log z base x. These four terms are in AP with your common difference half. Okay, so this implies that second term minus first term, that is 3 log x base y minus 3, will be equal to third term minus second term, that is 3 log y base z minus 3 log x base y, will be equal to this fourth minus third term, that is 7 log z base x minus 3 log y base z, and each of these differences will be equal to half. Okay, so this x base y, we can substitute this x base y with r upon pq here. Okay, so we have 3 times r upon pq, so this will become 3r upon pq minus 3 is equal to log y upon z is p square upon q, right? So this becomes 3p square upon q minus 3 log x base y, so this is again 3r upon pq, and then we have 7 log z base x, so this is 7 q square upon pr minus 3 log y base z, which is 3p square upon q is equal to half. Okay, so we are not going to solve for each of this question, for each of this equation. Okay, I am starting with this first equation, 3r upon pq minus 3 is equal to half. Okay, so from here on changing sides, we get 3r upon pq. If this 3 goes to the other side, 3 plus half, this will become 7 upon 2. And from here, if we solve for r, this will give us 7 pq upon 6, right? This 3 goes to the denominator, pq goes to the numerator on this side. Okay, so this is what we get r. Again, we are given that r is equal to pq plus 1. Okay, so we can substitute that value here. So this implies pq plus 1 is equal to 7 upon 6 pq. So this implies 1 will be equal to 7 by 6 minus 1 pq, right? I am taking this pq to this side. So this implies that 1 is equal to, this will become pq upon 6, right? So on cross multiplication, this gives us pq is equal to 6. So I can substitute this value again in this equation here, right? I can plug this value here. Okay, so this will give us r equal to 7 times value of pq is 6. Okay, so this gives us value of r is 7. Okay, so this is the first of the unknowns that we want to find out, right? We need to find the value of r minus p minus q. We have already deduced the value of r here. Okay, so again, now let us start with this equation, the second equation. Okay, 3p square upon q. Again, 3p square upon q minus 3r upon pq. This is again equal to half, right? So we don't know the value of p and q. Okay, so I'm keeping the first term as it is, but the value of r is known 7, right? So we can substitute 7 here, 7. And again pq, the value of pq is 6, right? So I can substitute that value also. So this becomes equal to half, right? So we get 3p square upon q minus, this will become, this 3 and 6 will cancel each other, so this will become 7 upon 2 is equal to half, right? So this implies 3p square upon q. If this 7 by 2 goes to the other side and adds with half, this will become 8 upon 2, that is 4, right? So from here, if I solve for q in terms of p, this will give me q will be equal to 3p square upon 4, right? Okay, so this is value of q in terms of p, but we are given this pq is equal to 6. Okay, so I can substitute this value here. Okay, so this implies that p times 3p square upon 4 is equal to 6, since pq is equal to 6 here. Okay, so from this equation, this numerator becomes 3p cube, and if I cross multiply this 4 to the other side, this will become 6 times 4, which is 24. So this implies p cube is equal to 8, and since pq are natural numbers, positive integers, p will be equal to 2, right? So this implies that we have got the second value. Similarly, q, since pq is 6 and p is 2, so q will be 6 upon 2, that is q is 3. Okay, so we have got all the three unknowns. So therefore r minus p minus q will be equal to, r was 7, p is 2, and q is 3. Okay, so 7 minus 2 minus 3, which is 7 minus 5, which is 2. Okay, so this is the required final answer. Okay, I have tried to explain it in a detailed fashion. Okay, you can skip a few steps, you can shorten the process. Okay, in the examination you don't need to show all these steps here. I have explained it with bit more steps here, so you can skip. If you know this logarithmic part, you don't need to show all these steps thoroughly. Okay, you can skip a few steps here and you can shorten the calculation process, but this is the required final answer. Okay, if you have any doubt in any step, you can highlight in the comments also. Okay, thank you.